So I just wanted to say a very warm welcome to everybody. Thank you for joining us for today's virtual company showroom featuring Nucleo, which is a company founded by CERN alumni. I'm sure you can hear more about that during the presentation. So many thanks to Elenia Piccolo, who's the recruitment manager, and also Alberto Domin, who is the Chief Business Officer, for joining us today. Nucleo, they have a very exciting mission, which is to generate safe, clean and inexhaustible nuclear energy, and they need bright minds to help them achieve this. So over to you, please, Elenia and Alberto. Thank you.
Thank you, Rachel. With Elenia, we agreed that I will start. I will give you some technical, say, high-level presentation on the company, on the technology, and then Elenia will give you more information on for what concerns the recruiting. Very good. So let me start immediately. So the mission of Nucleo is to provide the world with a source of energy that is at the same time safe, clean, practically inexhaustible, cheap, let's say, and on top that does not impact the climate. Now, this looks like science fiction, but it is not. And in fact, the message I will convey to you, I'll try to convey to you during this presentation, is that it is not a science fiction. We are actually very close to putting this into practice. Now, the company, Nucleo, started in September. It's a very young company. Normally, when you incorporate companies, you have a capital of, say, 10,000 francs or 100,000 francs. Nucleo was incorporated with almost $120 million. And somehow this proves, let's say, that the project we are addressing is a very concrete and attractive project. The headquarters of the company are in London. UK is a very nuclear-friendly country. But the research and development center is in Turin, in Italy, where we are in the process of hiring about 100 engineers and physicists. And we are now, I guess, we had almost 60 or 70 already. So it's, the process is going on very fast. We are also starting the building of the first prototype in Brasibone in a Enea lab. Enea is the Italian public research entity that deals with alternative energy and nuclear in particular. And then we are selecting sites in UK and France to build the first nuclear prototypes. Okay, so let's move on to the next slide. Okay, some of you may be surprised to see a private company dealing with nuclear energy. You should not be so surprised. Exactly the same thing happened in space. We are now familiar with SpaceX or Virgin Atlantic or whatever. And let's say what's happening is that a domain that was typically governmental domain is now being addressed by private capital. There are today 100 different projects dealing with nuclear, let's say, power plants or modular reactors. 30 of them have been started in the last couple of years, and Nucleo is one of those. So what are our, let's say, development pillars? We have three objectives. First, we want to replace water as primary coolant with pure lead. You're probably familiar with that, but if you are not, when you replace water with lead, essentially you can exploit the hard part of the neutron spectrum in nuclear reactors, which means that you can burn nuclear fuel much more efficiently. Say a couple of orders of magnitude more efficiently, which means also that you produce 100 times less radioactive waste. For the same reason, you can also use the waste from other power plants as fuel for fast reactors like this. Okay, so this is the most important feature of having lead as coolant. Now, in a second development phase, then we will also address the possibility of replacing the uranium cycle as fuel and introduce the thorium cycle. We are not alone in this project, as you know. And then couple the power plant with an accelerator driver in order to be able to design a subcritical system, let's say, by construction. So in practice, what we are doing is the following. This is the scheme of a typical power plant today. As I said, typically is cooled with water, so it's called a pressurized water reactor. We want to replace the inner vessels, so what is inside the containment structure, with our modular reactor, where, as I said, instead of using water, we use lead. Now, the steam generator is a sort of heat exchanger, which permits heat to be transferred to a secondary circuit. In the secondary circuit, you have water that then is transformed into steam. The steam feeds a turbine, and you generate electricity. Now, the idea is to replace the complexity that you see today inside the power plant with a very compact modular reactor, which has everything inside the inner vessel. And so the simplicity is probably the main feature of our design. Now, this type of reactor, so LFR means liquid metal fast reactors, are part of generation 4 reactors. In fact, we think that LFR are the most advanced type of generation 4 reactors, those that are closest to commercialization. And for what I was saying before, you can use it as a breeder, so you can configure it in such a way that you burn your fuel more efficiently, much more efficient than the current reactors, or you can configure it as a burner. In this case, it's more a waste-to-energy plant than an energy-producing or power-producing plant, because you can use it to burn nuclear waste from existing plants, but also from military sites. And as I said, the thorium cycle and the accelerator driver will be addressed in the future. Just a schematic view of the other advantages of lead. And this slide refers to safety in particular. Before I was, mentioning the advantages in terms of waste production. Now, safety, you see, well, lead is a very good shielding material, so it's ideal to shield a radioactive core. It has the advantage that it works at atmospheric pressure. Essentially, it does not boil. Okay. If it does not boil, it means also that it will not produce, radioactive clouds, even if it goes to high temperature. It has a very high solidification temperature. It means that if you have some kind of leakage, it will immediately freeze. It's also an element that is chemically inert, which means that it does not explode, it does not react, it does not produce hydrogen, which was the main reason for explosions in Fukushima and in Chernobyl. So we're designing a system that is, let's say, intrinsically much safer than existing reactors, where any chain reaction will die spontaneously in case of problems, and that cannot materially produce a radioactive cloud with volatile radioactive elements that could contaminate the area surrounding the plant. Now, even if Nucleo is a very recent enterprise, the roots of what we do are from CERN. And actually, they started a couple of decades ago. You might remember, for those of you who have at least my age, the presentation by Carlo Rubbia in the main auditorium, where he showed us his first concept of an accelerator-driven, lead-cooled reactor. That was 1993. Following that, there was a development of the concept through the years, with several milestones that I'm not going to describe now, but essentially we come to today, where we are now developing a reactor with essentially a final design. Okay, so what you see today is the result of 20 years of research, 20 years of experience and testing. What are the future milestones? Now, we are starting to prepare the site and build a first reactor. It will be a non-nuclear installation. This will be in Brasimone, in Italy, and we want to test essentially the, let's say, thermo-hydraulic fluidic properties of lead and the thermodynamics. At the same time, we are selecting 2 nuclear sites, one in UK, one in France, to start building a nuclear prototype. Initially, we will address a smaller, let's say, machine. We will build a smaller machine with a typical output of 30 megawatt electric. You will see later on why this is particularly interesting. And then with time, we will start developing the more standard 200 megawatt electric module. And then, as I said, in the next decade, we will gently address the thorium cycle and the accelerator driver. But already today, we are in the design and pre-building phase for phases 1 and 2 here. Just a few words on the design. I want to give you some more details about the reactor we have in mind. As you might have understood, the technology of Nucleo is very similar to the technology adopted in the Superphénix reactor in France at the end of the 70s that was operated for about 20 years. The main difference is that the liquid metal used in Superphénix was sodium, while we are using lead. And the key advantage of using lead is that it avoids the problems connected to using sodium. And in particular, as you know, sodium can take fire, can explode when it's in contact with air and water. And so that made the design of Superphénix extremely expensive and extremely complex. Now with lead, you avoid all this, so you can simplify enormously the design. And in this picture, you have more or less, the proper dimensions, so you can compare the complexity of what was built in Superphénix. This is a 22-meter high, say, structure compared to the 5-6 meter structure of the nuclear 200 megawatt reactors. And here, even smaller, you see the 30 megawatt version. This slide is also to show you how concrete the design is. Nucleo acquired the Hydromine company in its early days. Hydromine had developed a series of patents, and they are now an asset in Nucleo. You see here that the patents cover many technical aspects of the reactor design, and you see that the level of details is very advanced, and that we're almost ready to, asking for licensing and then starting the construction. Here you see how the reactor will evolve with time. Here you see the first, small prototype with a single pump that is being built in Brasimone in Italy. You see this is non-nuclear, so we will have an external source of heat to test the properties of the lead cooling. Here you see the 30 megawatt, what we call mini reactor configuration. The main applications for this reactor are, the maritime propulsion and, feeding electricity to remote areas or large industrial installations in remote locations or even, in non-remote locations. And then you see here the design of the standard 200 megawatt module. And here you see a pictorial view of how this module will be coupled to an accelerator in the future. This slide is just to show one important application of the mini reactor. You can imagine that we can put a sort of a nuclear battery into medium or large ships. With this type of nuclear battery, which is extremely small, the size of the 30 megawatt reactor would be, say the size of a minivan. You see, you put it in here, you don't need to use space for the fuel, and so this fuel area becomes available for cargo. And with this tiny battery coupled to a turbine and possibly an electric motor, since you have a source of energy for the propulsion, which should last for 10, 15 years, ideally for the whole lifetime of the ship. It is very safe because it's in lead, so even in case of an accident, you know, the ship will sink, and by flooding the area of the reactor, essentially you cool down, you freeze the whole vessel. It's very practical and cheap. It's the most advanced generation for reactors I mentioned. You will have zero maintenance, zero refueling for 10, 15 years, and on top you can increase your cruise speed by 50%. Today, ships tend to go very slowly, not to consume too much diesel. You know that the consumption goes like a third power of the speed. So by increasing the speed, you can actually take offline at least 1/3 of the existing fleet. That's it. I just want to conclude with a slide on the management and main founders. You may recognize Stefano Buono. Stefano already started a CERN spin-off in the early year 2000. It was an extremely successful enterprise. He managed to list it at NASDAQ later on in 2015 and sell it to Novartis for almost $4 billion. Luciano is the real guru of liquid metal reactors, a generation 4 reactors. He has been for 15 years the chairman of the Generation 4 International Forum. Elizabeth is also an alumna from CERN. Some of you might remember her from her early times at CERN. And then myself, Bruce, is the CFO, and Laura is in charge of communication. Bruce, Laura, and starting from next week, myself will be in the London office from next week. That's it. So this is the end.
Thank you, Rachel. Thank you, Alberto. First of all, let me say that it's a big pleasure being here today and have the chance to talk about our amazing project. I decided to join Nucleo because I saw the chance of doing something concrete and impactful for our future. The project itself is extremely ambitious and challenging. I would say that we have to face 3 main challenges. We have to realize, of course, the reactors. We have to ensure our commitment to next generation. And last, but definitely not least, we want to root out the prevailing opinion on nuclear power. We know that, especially in Italy, we have an evil legacy from the past, often related to, in my opinion, misinformation and sometimes also fake news. And we want to disrupt this mindset. That's why we are building a community of talent to join us and achieve together our goals. We receive a lot of applications during this month from all over the world. And I think that this is really amazing because it shows not only people awareness on the importance of this topic, but also our credibility to the outside world. I know that sometimes the word startup, because we are a startup, can be not so appealing and sometimes even scary. But let me say that we are an unicorn because we have the pros of a startup. I mean, flexibility, dynamic environment, and people, our people, can truly see the progress of their work because they are at the forefront. But at the same time, we are a solid reality. Thanks to, of course, our co-founder, Stefano Buono, Elisabeth Rizzotti, and Luciano Cinotti, but also thanks to our investors. Recently, 170 new investors joined Nucleo, and we are grateful for their trust. We conduct more than 200 interviews, and the recruitment process is still ongoing. We have open positions both in Italy, in Turin, where there's our center of research, but also in London, because our headquarters is in London and our purpose is to build a site there. I would say that one of our strengths is the mix between senior and junior profiles, because it allows Nucleos and everyone to have at the same time not only a proven and concrete experience from the past, but also, let me say, a new way of approaching by new graduates. Because we truly believe that working together, we can really make the difference for our future. Thank you.
Thank you very much, Ilenia, for that nice discussion or talk about the opportunities and why it's really a company that you think people should apply to. I was wondering now if we could possibly open the floor for questions. Okay, if that's Ashish, would you like to come on cam and ask your question, please?
Hi, so can you hear me?
Yes, perfectly.
Okay, so actually I have one question since I'm a just now I just finished my PhD and I have done this nuclear physics research program during my Master of Technology, and this was really interesting to me. What Alberto has shown me, and it was really interesting to carry it out this field in future. So I would like to ask a question to Ilaria. Like, I am an Indian, so how it's possible to apply for a company, or do I need to? I mean, what kind of procedure that I have to be go through to apply for the company?
Yeah, we are in contact with a mobility team to ensure the maximum smoothness in this kind of hiring process, because we have a lot of applications, as I said before, from all over the world, and we want to guarantee the best candidate experience. And so, yeah, you just have to apply, and then we will move through our mobility.
Okay, Ashish, I hope that answers your question.
Yeah, thank you.
Great, thank you.
So essentially, go ahead. That was the message. We take care.
I think that Radmila's mic is working now, so let's go back to Radmila. Oh, perfect. Yeah, we can hear you.
You
Wonderful.
can hear. Okay,
Yeah.
good. Thank you very much for the presentation. Very interesting. I am a student of technology and society, and so how technology influences society and society technology. And I'm from Norway, where is a big green shift, but in the same time, the nuclear energy production was completely out from the discussions. I have seen lately, couple of weeks, that it is starting to be maybe discussed that there is a new solution with thorium, without knowing in details what it is about. But if you could say, what are maybe pluses or advantages compared to other types of energy production, like wind and water, solar? Thank you.
Maybe that's a question for me.
Yeah.
So, well, first of all, you come from a very fortunate country, because if I'm not wrong, 94% of your electricity comes from hydroelectric plant. So lucky you. Unfortunately, not all countries are like Norway. So we have to find a reliable source of energy for every day. As you know, today, this comes from fossil fuels, mainly gas for residential applications, and oil or oil-derived products for transportation. Now, the alternatives are wind and sun. And again, not all countries are equally lucky in terms of amount of sun and wind. These sources are also so-called intermittent. Today, there is no cheap way of storing that electricity, which means that if you're at night and there is no wind, essentially you have no electricity. Now, I have to say that when Stefano asked me to join the company, I was reluctant at the beginning, and then I did my numbers. And if you do your numbers, you will discover that in many countries in the world, there is no way to cover the needs in energy and electricity in particular with wind and sun. On top, wind and sun, they should be done wherever it is possible, but they are not renewable per se. I mean, sun is renewable, wind is renewable, but the solar panels are not. You have to take care of them at the end of their lifetime, 20 years. So you have to recycle them. And believe me, recycling them can be very expensive, because we buy them from China, but we have to recycle them locally. And same for wind turbines. So again, nuclear is not perfect, but if we want to get rid of carbon emission, if we want to get rid of nasty emissions from gas and oil, unfortunately, we see no alternative. And, you're probably seeing what's happening in these days, in these years, having, a strong dependence on fossil fuels, irrespective of the climate effect and the pollution effect, can be very dangerous for a country. I end by giving you the view of Switzerland. I live in Switzerland, and the strategic plan prepared by the government is that by 2035, we simply have to reduce our energy consumption by 43% per person. Okay, so that's the only way if you want to shut down nuclear. But if you want to ensure the prosperity of a country, you have to go nuclear. And nuclear, by the way, in terms of track record, is extremely good. There are 300,000 people who died due to hydroelectric plants. My wife lost all her family in a tragedy generated by a dam in north of Italy that killed 2,000 people in one go. In Brazil, look at the state of Minas Gerais. Every 3 months there is a huge catastrophe generated by hydroelectric plants. So there is no the perfect solution. Frankly, we believe that nuclear is a very good solution, and this is why in the end we were convinced that we have to go this way.
Daniel has a question for, I think, probably Ilenia. Daniel, are you able to join us?
Okay, so my question is, I have two questions, one which is practical and one which is technical. I think most of the people coming for this sort of talks, they just want to know, or at least some of them, what do you need now in terms of competence, people?
We are recruiting for different teams. I mean, mechanical, thermal hydraulics, neutronic. So we need both physician and engineer at this stage. We are focusing on technical skills, and we are looking for someone that has a very good English, like all of you. Of course, Italian is desirable but not mandatory because we offer to our people, for example, language courses. And for technical skills, I will remind you to Alberto because it's much more into than me.
So you need the people to do the calculations and integration of all your components.
Sure.
Okay. Into some fabrication phase.
Yeah, there are some
Later
job descriptions. I don't know, Daniel, if you had a look at the precise job descriptions.
I looked at them, but
they're a bit vague.
I prefer to talk to people, you know. For me, it's easier than going and reading everything.
If you write to us, we will put you in contact with the technical team so that they will tell you specifically what they need.
Are you doing simulations in your equations? I mean,
one of the positions, if I'm not wrong, is in simulation. Yes.
So you introduce all your variables, your concepts, and everything into a simulator. And
it's a typical Monte Carlo simulation, similar to what you would do at CERN. Very similar.
Yeah, I understand.
Simply, we have to deal with neutronics, so it's a bit more.
Exactly. You know. Neutronics, I think, is the word, and I think it's there where people from CERN could help you really. I mean, people who were working on simulations in high-energy physics might be well fit to do all these type of jobs that are related to simulations in your small reactor.
Yes, but please write to us. We will put you in contact with the people that are in charge of those positions, so they give you all the details you need.
I think even people who didn't work in simulations but are good enough, they can learn it fast. Now, the next question is about, when I go in the streets, I see hybrid cars everywhere. Electrical and thermal motors together wherever I go, yeah? Is there anybody thinking about an hybrid reactor which would use fusion and fusion together? This is unrelated to what you're talking today. I'm just asking an external question.
Well, I don't think this is possible today. I mean, I wonder if there is any advantage in doing that. In some way, if you think of fusion, fusion needs fission in any case, because you need to produce the tritium that then you need to feed your fusion. So probably the best way to produce tritium is by fission, because it's not easy to have a breeder with fusion. You know, losses are important. It's extremely difficult to have it to have a sustainable fusion reaction. Now, honestly, I've never thought of coupling directly. You mean in the same installation, fusion and fission? To me, fusion is already science fiction. Now, if you say fusion plus fission is already, you know, it's science fiction to the second power. So for me, it's not something we should focus on today. But again, if you come up with a viable idea on that, we should look at it. But honestly, I don't think this is viable today.
Okay, many thanks.
Thank you. Thanks very much. Thank you for your question. We did have a question from somebody in the chat. They're unable to come on cam. So the question was, are there any positions for people who are working in IT at the moment? I think that on the platform, we didn't have any that were posted.
Right. Right, they're not posted because we're mainly focused on technical, so I mean scientific and finance positions. But on our website, newcleo.com, we have a section called Join the Team, where candidates can address their application even if they don't belong to a scientific team. So I'm sure that our IT colleagues need support. So send your application.
That's wonderful. Thank you. So Kaiton, you've heard, you can go, you can actually probably find Alberto's connection details on alumni.cern. So you'll be able to contact, I think, Alberto Alenia. Thank you very much. Now we have Kevin, who's been waiting very patiently to ask his question. Kevin, would you like to go ahead, please?
Yes, thank you. So I'm Kevin, I'm an alumni engineer as well. So thank you very much for the presentation. I buy it, it's a wonderful project. And I had a question about the end of life of the product, because for me it sounds like you said, science fiction in the real. And what about, so you don't need maintenance, you don't need to refuel, but if you need it, what about the end of the life of the product? What you will do when or do you have end of life of this project?
Yes, okay. I'm not the expert on this topic, but I can give you some highlights. You know, one of the advantages of lead is that it protects the external environment from radiation coming from the core. So intrinsically, you have, you know, less elements, even of the surrounding structure, which is contaminated. Lead is 11 times more heavy than water, so you can actually miniaturize your reactor. Reactors that we are proposing are very small. When you have a small element to dismantle and to take care of at the end of a lifetime, everything becomes easy. If you take the 30 megawatt, you can even, you know, pick it up with a crane and move it to a place where you can, you know, take care of in the proper way. You can put it in a lake. You can even decide to keep it as a closed, sealed sarcophagus for the rest of a lifetime. Second point, you know, by the fact that we burn much more waste, even the amount of waste we produce is much smaller, and we actually help reducing the amount of radioactive waste from the other reactors if we operate our reactors in a burner mode. So, you know, honestly, we believe that this technology has many advantages also in terms of, you know, dismantling and decommissioning, because it's more compact, it's better sealed and shielded, it can be transported, it's modular, it's small, compact. So in the end, we certainly have a lot of advantages there. To reassure you, I tell you that we are already discussing with the ONR in UK, so the Office for the Nuclear Regulation. And in order to be able to start, you know, building a plant, so to get licensed, you also have to prepare a detailed plan for decommissioning. So don't worry, we will address this. You know, again, first impression is that everything should be much simpler than in a current reactor, and much simpler, for example, than fusion reactors, where you have fast neutrons going essentially everywhere. Here, everything is contained within the vessel, the inner vessel, and the inner vessel itself is very compact. So I don't know if I answered your question. If you need more detailed information, I can come back to you with an expert telling you exactly what we are planning to do.
It will be with pleasure. Thank you very much.
Thank you.
Thank you, Kevin. So now we have Chiara, who has a question, please. Chiara, would you be happy to come on cam, please, and ask your question?
Yeah,
thank you.
Thank you very much. It was a very, very interesting presentation. So my question is more, again, in the direction of recruiting. So I was wondering, I looked quickly at your website and the positions that are open, and I see that, of course, you need a lot of nuclear physicists with experience in this direction. But I was wondering if you consider also useful to have some application from people that have like a physics, nuclear physics background, but not really, you know, worked it through in the nuclear energy direction. So because of course there is a gap in the knowledge, of course, so I can understand it, but yeah, if you have also interest in people that have an industry experience, a physics background, and maybe want to go in this direction.
For sure, we need different backgrounds because it's really useful for our growth. It's a good mix to have different profiles in our company. So yeah, it's a great combination.
So maybe, I mean, if you said already that there is a section in the website where one can apply freely.
Yes, but you can send directly to me.
Yeah. Are you? Yeah. If you're also like available for like a discussion,
For sure.
just to understand in which direction one could go, that would be very interesting. Yeah.
Okay. It will be a pleasure.
So I will contact you. Thank you.
Thank you, Chiara. We have Ashish who's come back with a second question. Ashish, please take it away.
Hi, so I have one question. Since we are using lead, so do we have the issue with the conductivity of the material in this? So this is a question to nuclear physics based actually.
Sorry, can you repeat the question? I missed part of your sentence.
I mean, since I don't know, do we face this conductivity issue in terms of like sodium and the water, they are liquids, but the lead, that's not it's in the solid way. So, I mean, in terms of heat transfer, how we see the conductivity of the material?
Well, sodium is better from this point of view, but lead is okay. So after all, it's a metal, it's conductive, and it conducts heat in particular, which is what you want if you want to be able to evacuate heat in an efficient way. So I would say, lead is appropriate. It's not the ideal material for its thermal properties, but it's relatively good. So we don't see any problem from that point of view.
Okay, and another question is we have this nuclear fuel, if I remember, it's a thorium. So what's the issue with the plutonium? Because plutonium has the more number of output neutrons in terms of like thorium.
Yeah, that's a good point. So if you want to have a sustainable chain reaction based on thorium, you have to deal with the fact that you produce 2.1 neutrons per fission compared to, I guess, 2.4 that come from plutonium, which means that you have to be much more efficient in reusing those neutrons. Because if you want to have a breeder, you need 1 neutron to breed fertile material into fissionable material, and you need 1 neutron then to produce the next reaction. So essentially, you have to do everything while losing only 5% of your neutrons. This is a challenge. And if you want, to my understanding, this is why Rubia, when proposed the thorium cycle years ago, he thought that the accelerator driver was kind of needed. It was needed to supply the needed neutrons in case you are not able to have a self-sustained reaction. Because thorium produces less neutrons than plutonium. So it's a good point, and this is why using thorium is not for today. We really need to develop research, and probably it will need an external source of neutrons.
Okay, thank you.
Okay, we go to Haroon in the UK. I think has some issues because of the storm, but take it away, please, Haroon.
So hello everyone. I apologize if I disconnect. Yeah, we have storms and my electricity keeps cutting off. I just wanted to say, first of all, congratulations on your mission. This is a really important thing that you are aiming to solve, this problem. My first question is about the thorium enrichment process. The last time I was involved in this was like 2014, and the last I heard that there is not much work that has been done on the thorium enrichment process to get it to form of a fuel. So has there any progress? Has there been any progress on that?
Personally, I don't know. I don't know if anybody in the audience has anything to add. What I can tell you is that even the uranium enrichment process is a difficulty, because since every country is dismantling their nuclear energy supply, I tell you, it's very difficult to find companies that still do processing of nuclear fuel or reprocessing of nuclear waste. And believe me, we are thinking of rebuilding ourselves that supply. So thorium, I guess nothing has been done so far. I wonder if anybody in the audience knows more than I do. If in that case, please intervene.
Well, the UK has stockpiles of thorium that are doing nothing, so I assume there is no enrichment process.
That's also my conclusion, yeah.
another question, your small reactors that could power a ship, is it the aim of Nucleo to mass produce these, or to just generate the designs and then keep the patents?
Well, this is an easy question. We want to mass produce them. You know, the market for this type of reactors is $100 billion market. We are probably among the first comers, if not the absolute first comer in this. We have the perfect solution according to us. For example, you might know that the Alpha class submarines built by the Russians during the Cold War, they were using reactors based on liquid lead, well, lead bismuth alloy, but it was, you know, the perfect solution for vessels. So the answer is yes, we want to mass produce them. If you ask Stefano, we will become the largest energy company in the world, or power generation company in the world. But yes, the answer is we want to do it in scale and in mass.
So then just a follow-up, thank you. Where do you aim to have these production facilities and maybe these enrichment facilities?
Well, as we said at the beginning, we are now talking mostly with France and UK, because they are the most nuclear-friendly countries in Europe. At the same time, we are now discussing with US. US is also very generous if you set up, you know, this type of companies on their territory. We are signing deals with industrial players that are present both in Europe and US. And then, of course, we can think of you know, Japan. We can think of India, especially for thorium. India would be interesting. So we will develop in those countries that offer us the best condition for development. And as of today, I would say France, UK, and then later on Canada and US.
And thank you very much. And thank you for your presentations.
I saw in the chat a question by Daniel on the cost of the reactors. I think it's maybe worth discussing that very quickly. So we don't know yet, but given, you know, the small amount of material you need to build such a compact reactor, we believe that we can build those reactors in the range, let's say, $3 to $5 per watt per you know, electric power. So let's say a 30 megawatt reactor, 30 megawatt electric reactor, which means 100 megawatt thermal, should cost, let's say, order of $150 million. If we are in that range, then we are absolutely competitive even with diesel. Okay, even with the current cheap, you know, fossil fuels. If we compare this price to the closest or cheapest replacement, green replacement, like, you know, biofuels or biomethanol or this type of fuels, then those fuels are about a factor of 3, or expected to be. Now they're even more expensive, but in the future they're expected to be a factor of 3 more expensive than diesel. So our reactor can be even, let's say, 2-3 times more expensive than what we plan today, and we would still be in business because it would still be, let's say, in good competition with green replacement for fossil fuels.
Thank you, Alberto. We have another question from Luca in the chat. He's not able to come on camera, so I'll ask it. It's related to your second phase, that he noticed the coupling between the reactor and accelerator will come in your second phase, but are you interested in accelerator physicists and related expertise at the moment?
I think that it's something that will come later. Yeah.
I would tend to agree.
Okay,
Sorry.
so but then keep your eye, Luca, on what's going on with the company.
Oh, yeah.
So mainly, could you just give us a recap again, please, Ilenia, about the types of profile really that you're looking for now, what sort of skills, etc.
For sure.
Thank you.
We are looking for mechanical analyst and designer, thermal hydraulic analyst, neutronic, and safety and licensing, mainly in Italy, I mean. And in UK, we are also looking for the finance team. The main skills are related, I guess, mainly to the physician and nuclear engineer, but we are trying to balance all those skills. For the technical ones, I remind to Alberto.
Yes, but essentially you understood we now need to move on to a final design phase and pre-construction phase. So we would need people really hands-on, either on neutronic simulation or mechanical design and construction. If I can wrap up the phase where we are now. To answer the question from somebody before that asked whether general physicists would be needed anyway. Well, the answer is the following: that ideally we need people who have experience in nuclear power construction and operation, but the reality is that those people do not exist. We have to keep in mind that this industry has been gradually dismantled in the last 20, 30 years. So it's very difficult for us to find people who have experience on nuclear reactors. It's a fact. So anybody who believes he can adapt himself and has the right skills to help us, even if he has never worked on a nuclear power plant, is welcome to apply.
Thank you. That's a very nice way to wrap up. So basically, I think the message is, if you're interested, then please go ahead. Thank you so much again, Ilenia and Alberto. I wish you every success in your recruitment drive and for your company. Thanks everybody for joining. Have a lovely Friday and even better weekend. Thank you very much.